Reflection attack, as I was saying, the attacker, what happens is, first of all, the reflection attack is mainly used in denial of service attacks, in most commonly in distributed denial of service attacks. What happens is that the attacker spoofs the victim's IP address, and then it initiates a large amount of requests with that spoofed address, and then the session responders will reply to the victim, flooding it, causing its service distributed denial of service. Like, for example, so it takes reflection attacks are going to end up in DDoS attacks, but they make use of IP spoofing. So let's say that in my case, router 4 is the attacker. This is the attacker. And test server A is the victim. And the victim has a valid IP address of 1.1.1.1, let's say. That's the victim's IP address. Now, for the reflection attack to be successful, what happens, the attacker spoofs that address of the victim. So the attacker is going to make use of that address as the source address. He's going to spoof the victim address, and is going to send, let's say, large amount of replies to a specific destination. For example, let's say that I'm going to have in here a NTP server, which actually happened. The NTP service reflection attack happened, and we have a link on that on the slides. So the attacker is going to send huge amount of NTP requests to the NTP server. So NTP requests with the NTP server, but with the spoofed address of 1.1.1.1.1. So what's going to happen from the NTP server point of view? NTP server is going to say, oh, 1.1.1.1.1 is asking for my NTP services, so I need to reply to it and provide him the correct time. So what's going to happen then, the NTP server is going to build up an NTP reply packet and send it to 1.1.1.1.1, but of course the NTP replies are going to be sent to the victim, right? Because the source of the NTP request was spoofed, which means when the NTP server replies, it's going to send all of the replies to the victim. And it's called an NTP reflection. It's called a reflection attack, because it also makes use of protocols like NTP. Because how NTP works, you have, let's say the basic functionality, you have a client and a server. But how NTP works, the client says to the server, hey, I need to synchronize my time with you, and then the server is going to say, okay, here's the time. But the synchronization doesn't happen in one step. So based on the time difference of the client as opposed to the server is going to end up sending many replies to the client, because for the client to come up to date, to synchronize its clock as to what the server's clock is, that happens incrementally. So if the client's clock is 7 p.m. and the server's clock is 11 p.m., then the client's clock will become 11 p.m. not in one packet, not in 1 second. It's going to take a lot of time, like it can take minutes or hours for the client to actually synchronize with the server. But for the server, for that to happen, the server, as a result to one client request, the server is going to send multiple replies to the client. So that's why it's also called a reflection attack. This is based on IP spoofing.